Welcome everyone for Cloud Computing and Big Data. Now we have our practical lecture 5.1 part 2. And this is about understanding MapReduce in different clouds. Like for instance, we have seen in part 1, the idea of using again MS Azure for MapReduce applications. And we have learned a little bit already in conceptual lecture 5 that MapReduce, inspired a little bit by the idea of divide and conquer, is really more or less a computing paradigm. Very good for high throughput computing, HTC tasks. And there are many of those that can be working, let's say, embarrassingly parallel, or as people would say today, more nicely parallel, and then do some basically break off and basically put all this data in parallel, work on it in parallel, and then basically have some summary statistics or basically merging at the end everything together. So this is something which stands the test of time, and I was alluding earlier already is also a bit different that we have in high performance computing, the other course I teach, where there are lots of interactions and every little iterations between the different parallel entities, while here the parallel entities are basically alone from each other until they maybe sometimes merge. We have also learned that the idea of using key values is inherent in the implementation framework, for instance, from MapReduce, like Hadoop, for instance, so that you also understand that MapReduce is really more a map, sort, shuffle, group, and then a reduce. Hence, the framework grouping elements, data elements by keys is an important part to understand this paradigm. But before we repeat too much on this, you have the different lectures to look at. I will try to go now a little bit more ahead in the part 2, and will also show you that, for instance, the idea of using Spark, like we have used already in MS Azure since quite a while now, is also possible with other cloud computing vendors, with other hyperscalers like the Amazon Web Services. And this connects us nicely to the idea that we already started with. So when you think about the MapReduce idea, we want to see now, basically, can we have similar applications as we had before by moving essentially from Azure to Amazon? And you will see that the Amazon EMR stack, the Elastic MapReduce, offers you again Apache Spark, Hive, Presto, and all the other big data frameworks that we already know from MS Azure. Although, of course, the idea how you configure these services, how they're arranged, is a little bit different. But still, the underlying concept remains of providing really this big data stacks integrated with different versions, as you will see today. So let's connect again to our idea that we also had in the last part, basically in part 1, that we started a little bit with the idea of looking into Amazon from the kind of idea of the key creation, right? So I'm logged in here again in the Amazon console. You see that Ohio is the region we are in. That's an important part. So when you create clusters, when you create keys, when you create S3 buckets, all of that has some relevance to specific regions. And you see also, basically, we have here something in Europe, Frankfurt, Ireland, London, and so on, or basically in other parts of the world and Asia. So you can orient, of course, these, let's say, services already towards different customers in different regions and combine them. And here you see also quite nicely that I have used already a little bit the Elastic MapReduce stack here, together with the EC2, which comes below, as you remember. This is, of course, the computing entity, very similar like we had in MS Azure. You see also here now we can do the same in Amazon, the computing itself, then the Elastic MapReduce that we have on top, which are then these managed big data frameworks really that you have there on top. And you have a cost overview of this. We were referring to this also already to the instances, and will bring today again the idea how this now looks like in the Amazon world. So let us recap a little bit part 1 briefly. When we said we also wanted to create keys, we go to the EC2 area where we think about this is the lowest level, if you want to, on terms of computing elements that we're going to use again when we create an EMR service. And we created some key pairs which were relevant for Ohio, this new key pair, right, which alluded to SSH we learned in the last part, where the private key stays on the laptop and the public key you can actually upload to get access via the SSH protocol. We're going to use this key pairs now in Amazon in order to really create this first EMR service and bringing us a little bit back here to the concept. Of course, we have this subscription here. We always have to think that this is, of course, the first to start. And then we want to really deploy a Spark cluster using now this AWS Elastic MapReduce. And we will see by preparing this computing infrastructure, it has very much similarities like MS Azure. Then there's an optional startup of the Jupyter Notebooks. You can imagine also Amazon enables us to start this Jupyter Notebooks to work on the Apache Spark service. I will bring this just briefly because here with Amazon, I want to show you also different things. And one of them is the, let's say, very famous S3 service with a bucket store. We talk about this, although in lecture 8, we'll talk about much more about it. But here it is an interesting way of uploading an application code, so a Python script, and then also uploading the application input data set. Then if you deploy this Spark cluster then in AWS Air to execute then the Spark application on it is an important concept, where of course similar aspects like the head node, if you remember, or the worker nodes and so on come back to us to understand how basically then the Spark application is executed. And we have some small data analysis and later look at the cluster. Hence, it is a little bit of different idea today, not only AWS services, but also we want to just have a Python script and not work so interactively with Jupyter Notebooks. I still show you some relevant ideas how you do this in the cloud with AWS briefly with the Jupyter Lab, but the real demo should be much more on the Python script. So again, important concept, create your subscription. You basically had this here already where you think about, okay, there are different offerings of AWS. Educate has not anymore an EMR service, Academy only in some courses, and the free tier is also not anymore offering us Amazon EMR. So hence you have to swipe the credit card here. You have to give the credit card, and then AWS is differentiated between two types of users. One is a root user, so where you can basically undertake lots of configurations and being responsible for many of the different services you set up. And then you can configure different users, which are then this kind of identity and access management user that you can actually prepare for maybe other employees in your companies. If you as a CTO, for instance, and your employees in the company want to use this cluster, you can use a system that the CTO remains the root user, but all the other employees in the organization will become an EAM user and will get access to this cluster. So a very smart idea, again, of allowing a multi-user environment where these clouds are, of course, can point very much. You see here some offerings of the free tier, the EC2 hours and so on, but not really you find the EMR service there. So still, let's go a little bit to the idea of now doing a practical lecture. Let's go and now finally create this EMR. You see here we go to a specific area in Amazon, where you have already many different clusters from me. You see here already started. They are terminated with a nice feature called auto terminate. And this will be an important feature we talk about when we create now a new cluster that we call again, maybe the CCBD cluster. And here you already see familiar elements, right? Firstly, you see Spark, of course, but also Hadoop, Core Hadoop, Apache Flink for streaming, HBase for databases, and so forth and so forth. You also will realize, okay, they all come in different versions, right? Spark 3.5.1, for instance. Now, when we move back to an Amazon EMR release in the past, in the 5 regime, you see, oh, suddenly Spark 2.4.2. And here you see already now the benefit of this idea of the service offering of the managed cluster, really with Hadoop, with Spark, with all the different versions that you see here somehow interplay with each other. Hence also justifying so many different versions here, right, on this. Because always when one, let's say, open source package moves, the all others have to come along. And there is also familiar elements like Jupyter Hub, Jupyter Enterprise Gateway, MXNet, and TensorFlow are actually packages for deep learning that we will learn in lecture 6 on Thursday already. So very different tool. You remember Zookeeper, for instance, and so forth. So let's just pick now and kind of recent EMR release. Maybe we can see here some differences in the versions, but you see there, so to speak, also minor from Spark 3.5.0 to 3.5.1. Let's create the cutting edge here, 7.2. And here we can, of course, click and now pick what we really want for our services. We want maybe Jupyter Hub as an example. And you see it's already switching to custom because now I add on services which are not in the normal distribution, but it doesn't matter. We can still add this here and, you know, pick what we need. We can also use our elements that we similar have also done in previous times. We use this Hive table for metadata. And then you come to further, let's say, configurations, but it's also nice to see that the Amazon console improved. You see on the right-hand side now new elements that have been introduced since last year, where you have a bit of summary over all what you have to do. You see name and applications clearly required. This is this area, but you can imagine what's next will be the cluster configuration. And the cluster configuration you already know. You can imagine the primary, the core, and the task, where they stand for, like this master worker paradigm. Now, Amazon comes with an interesting idea of saying the master is clear, the primary, you have a specific, let's say, instance type you want to pick for this. We use here just the ones that is given. You also have nicely directly the costs associated, which I found quite interesting in this. And the difference now between the worker in terms of core and the task is really that the core essentially would have data associated with it. Remember the data locality that we introduced before. And the task is simply a computing task that can basically run everywhere, right? So by having this distinction, you can, of course, optimize your cluster a little bit more. In the moment, we just leave these instance groups that they are now uniform. So everybody from these has, of course, now the same type of resource, and you can, of course, switch them. You see the different sizes. You can imagine almost like MS Azure. You have different memory hierarchies. The more you pay for gigabytes of memory here, like large, you have suddenly $3 per hour instead of $0.1 or so. Hence, here for the training and for the demo, we don't need the cutting edge memory. I have also an application which is not so you know, crucial to have so much memory. Now you also remember a little bit from what we have discussed in MS Azure. So we have to say how many of these instances we really want, right? While the primary is given, we can also play a little bit with the number of resources we have here now for the different cores, for the different casts at hand, which is now basically alluding to how many workers you really want. And this is something what you can scale up now in one respect, but there's also an auto-scaling function that you can actually apply to these. So here we've just picked, let's say, 2. Then there's a networking that will be more or less automatically here configured, but lets us also, of course, play around it when you have more advanced solutions. Steps is something I come to later when we want to also do some Spark application. You can also do these steps later once we have created the cluster. And then for the cluster termination, that is an important part. You have seen it in my overview. I was alluding to it. You basically can set rules like automatically terminate a cluster after idle time. So when it's not used, you remember, even if it's not used, it generates costs, right? So what you want to avoid is that someone goes into the weekend, has a whole weekend, an idle time of a cluster that's never used and still generating costs. Hence, you have here a nice element of, for instance, after 1 hour, you can say, if nobody uses a cluster in 1 hour, basically terminate the cluster. And this is a good tool, especially maybe for smaller companies that quickly can run into big trouble when there's money spent for this, which you basically can avoid by setting these rules. So also quite nice to enforce this rule, and it really works. As you have seen in my overview, most of them are always directly terminated or automatically terminated after 1 hour. Several other, let's say, more advanced options. I don't want to really go into this in this small demo because time is ticking and we have just 40 minutes to show you a lot of actions here and a lot parts actually of the AWS services. In one respect, you can have and teach, of course, again, a whole course on AWS services. It's a really rich software, and even the EMR service has quite powerful functionalities, as we will explore. So here we connect now nicely to the idea that we had already introduced in part 1. So we have to enter here a key pair to access to the cluster when you want to access it, for instance, with SSH, and then submit some jobs, for instance, or basically want to access it in other ways via your SSH clients. Then an important part I have also here put already early is that you have certain security configurations, and this is now alluding to this EAM users and so on. So giving others access to this cluster, right? You set certain security configurations, and we will have a look in this basically to see how that works. And there's also no basically big surprise in this. You can imagine that there's one interesting security configuration, and this is now alluding to how you have different options that you use, for instance, this AWS identity and access management for it. Then you would go to something we call users and groups. I show you once we have created maybe a cluster and how this now comes together with the identity and access management. But this is something where this has to be done, and this is now important really at the beginning. Otherwise, you have not these policies about the security configuration we will talk about not implemented, right? So you really have to do this once the cluster is created. Coming also now to the idea of using this identity access management, there are certain service roles we have to engage in, like the default role here for this, and also here the EC2 default role, which has to do something which means that services can access, let's say, the underlying EC2 instances. You need a certain, let's say, access management for it. And you see also quite nicely in custom automatic scale role, right? So you can have several rules that are sometimes triggered when you want to extend your cluster automatically or also shrink it again. And for this, you need also some rules. This is actually kind of optional. We don't need it right now for the smaller cluster we have here. So in this sense, this is really all in the beginning, what you have to do to create such a cluster. So let's do this. And you will notice that this takes a little bit of time. So we have now the CCBD cluster. The status is starting. So this seems to be good. We have here a bit version information. We have the information then depending on that version, what exact technologies we have here, the ones actually we clicked on. And then several tabs here, which are quite important. Here, again, an overview about all this cluster logs, activities. We have some instances which are quite important for us because we said we want to have one primary, 2 cores, and 1 task. So you see here 0 and 1 requested. So this is in provisioning. So basically we talk about it's actually now getting scheduled, getting deployed. And then on top of it, we want to, of course, have several applications. So these applications are in so-called steps. We can have later add a step with different functionalities, streaming, Spark applications. We have to cancel here and wait, of course, until the cluster is really up and running, right? So we have to wait in the summary here, and this could take up to 10 minutes to really get the cluster into a so-called waiting state. Hence, there are different elements here that are smaller parts of the configurations we talked to again, and some monitoring elements we can activate and so on. So a bit more advanced material. But I think using the time of the 10 minutes now where this is starting up, I would like to advance a bit in the slides as well, so that you see that whatever I talk to, very similar elements are basically also captured in the slides with some explanations more that maybe some of the things I maybe missed by the demo, but it captures essentially the essence, what I hope to present here in live to create such an EMR. And you have seen it's actually not that much of a deal. Again, think about the pricing, right? This is an important factor in cloud computing in general. Here you see again the different ideas when you pick these instances. As I told you, you see nicely directly the prices here. which reflects really what they also have on the website. So you see basically this is the same price ratio. And if you want to then go into really memory intensive elements, more memory, then of course here you go and have to pay the price for it. You can change this, of course you can change the instance types, but you also have to think and consider the cost, which is, very similar elements that we have also learned during, MS Azure. These are now, of course, the Amazon costs. There's a certain different spots and on-demand pricing, also a little bit an advanced concept. Because of the sake of time, I cannot go in all the little details. But of course, it's something to explore in order to save some costs here and there. And I was also explaining already the difference between core and tasks here, for instance, which is important distinction here, because this is a bit more on storage as well. And here the idea is having tasks everywhere running. This is what I already talked about, so I think we can skip this. I was just saying this, here, of course, we can now scale up and scale down the cluster. We can do managed scaling. So this is basically something where the resource utilization will be looked at, and then scale down the cluster again. So a bit more dynamic behavior, also very nice. And again, the warning goes, the more this cluster is running and having more worker nodes, the more it costs, right? Hence, this auto termination is quite effective if you have, for instance, 20 workers instead of 2. Now, an important element to connect it also to part 1, when we said key pairs are sort of important to really log into your cluster when you don't want to manage everything via the steps, via the applications. Real experts go often via SSH into this, but users of the clouds usually not, but this might be the technical experts, the CTO of a company that is preparing elements, and so on. We have talked about the roles. I think that is pretty clear, and the custom automatic scaling, which is also possible. So this all affects now how the Spark cluster is basically configured with all the different tool sets that we have picked. And this is what's happening right now. I think you can imagine this was very similar with MS Azure as well, to deploy the cluster, to prepare all the software that is ready available, and that the, let's say, scheduler, yarn and everything and PySpark is available, take some time to really for the cluster to manage. Hence, this is something where you sometimes at least have 10 minutes to wait. You see here in the other example I took here, for instance, it took even 12 minutes or so. But yeah, once this is up and running, and this is then the first time where you should actually then do something with it, right? So you have to carefully wait until there's a waiting state here, that the, let's say, Spark instance now is waiting for your submissions, for your steps in the applications, for your Jupyter, etc. It depends, of course, what you want to do. Another way to see that really is in the instances that they are all running, right? And when we quickly go back to the idea of the live demo here, and when we refresh, it's probably still in the starting phase, and the hardware is not really running, but you see also some of them are already bootstrapping, so already starting to get the cluster together. It's the next step, basically, once the hardware is almost there, that you basically start with popularizing your cluster with the access and so on. So we just have 5 minutes here, so we can expect this will take at least probably 5 minutes more or so. Hence, I would like to spend the time further to advance a bit in the slides, so that when we do some more demos, everything goes a bit quicker. Bring us also to the idea of how to start up a Jupyter notebook. As you know from MS Azure, this was possible, although the sharing of it was not so easy, as you remember from the assignment, right? So there were some certain passwords to be used. And here is a concept a little bit more elaborate. So here you would say you need first, and this is a new element also, I marked it as new, that is from last year introduced, where you have some workspaces, and they are connected to so-called studios. Hence, you have studios and then create workspaces. And these workspaces enable you then to create Jupyter and to create, other things. And they can be then attached to a cluster, right? So hence, this is something which is a little bit more than just an MS Azure click on the Jupyter Notebook dashboard, and then you're happily there. But the idea here is also that you can do the sharing of these notebooks and so on a bit more controlled and a bit more in line with all the policies that you have. And speaking of the policies and the permissions, this is maybe one of the things that it can be a bit challenging here, because you will see that quite the security groups and the permissions that you have to put per user, I will come to this in a moment, are quite elaborate, because they have to have lots of rules and permissions set in order to enable then these steps. And this is all, of course, to protect the cluster of being used or misused. Let's put it like this rather. On the other hand, it adds significant complexity to a kind of hierarchy that a startup can be overwhelmed with this, right? So you have to really dive into the security elements, how you do this. It has also here and there some network implementation issues. So you have to configure VPC network to this before you can even attach a cluster. So hence, it's a bit of material where before you come actually to start up the Jupyter Lab and the Jupyter Notebook, you have to quite read up a lot of things. And I cannot teach that all in a couple of minutes here in one lecture, but it's possible, right? The startup of a Jupyter Notebook is there. You can have different access restrictions based on this EAM profiles, so users in AWS with different permissions. And this is also something I want to show you when we go now a bit more to this IAAS while we wait for the cluster to start. But you see, it's actually waiting already, so it's good news. Our primary core and tasks are also running, also good news, and it took just 8 minutes. I still would take the time to do what I promised you from the slide. So let's go a little bit into this EAM, which we have here, which is the identity and access management. So here you can configure nicely different users. You see here, Morris, for instance, no surprise, that's me. But now the interesting thing is when you remember what I told you about the login, right? Here I'm Morris Riedel as a root, here on the top right in my organization now. But here as this Morris, I configured myself of being a user in the EAM. And as I would configure now all of you, students or other people in my organization that want to have access to the cluster. Hence, when I log in as Morris as a root, it's different from when I log in as Morris as an EAM user. And you see also the permissions that I have to give here to enable that you, for instance, get access to Amazon EMR, right? You have to change this all. And the good news is you don't have to change this individually. Hence, we're talking about groups, right? This is something called user groups that luckily exists. Like here's a CC and BD, our course group, for instance, as an example, where I give permissions on the group level and then can, of course, ask different users to be part of it. And this here, all of EMR, specific ones of EMR, the studios that we have here in Amazon. And then you see also S3 is important, the storage I will talk to about in a moment as well. So hence, this is how you enable now different permissions that you are able actually to use the cluster. And with this also in a manner that you don't are the root anymore, basically just a user of the cluster, right? And a little bit is here also shown this in the slides. You see, I don't want to now log out and log in again to show you this. So this would take too much time, but you see here, I'm the root. And for having this access, we have the security policy in place. And when I do this now here as Morris at the CBD course, then you see here I'm logged in as EAM user, but see the cluster as well. And that's nice for sharing the cluster with, employees of your company. And this is basically possible because we configured it before in the security configuration that we use a CCBD core success for it. And this is instrumental then for having a sort of hierarchy of users that can access in the Jupyter Notebook. Still, as I said, it's important to set the right policies. Otherwise, you get lots of errors when you want to, for instance, attach the cluster and so on and so on. So in other words, let's progress a little bit here to the next steps. So this is the Jupyter Notebook. And when you have this here in the, let's come back to the EMR console part where the clusters are now happily awaiting for our basically idea of being used. You have here on the left-hand side now the idea of the workspaces I was alluding to, which is new. right? So you basically have to think about that you want to have studios and notebooks, and in the studio you basically have to create a studio first. We do this here, for instance, create one interactive workload. That's what we want to do. And then in this studio, there will be a workspace. And then this enables us also a little bit a more consistent picture how you can do this in terms of also thinking about other users that should now go to the Jupyter Lab. You see the Jupyter Lab is starting up. No surprise, this will be the Jupyter Notebook environment. You already can imagine it looks very similar like MS Azure. You have here different kernels, Python 3, but also our PySpark kernel, for instance. You have even Spark Air. Air is another language where you can have data science done with, and so forth. And then you would start with uploading your script, like the MapReduce script we have uploaded in MS Azure, or what you already know via your assignment. So hence we are talking about very similar elements here that is possible in the IAAS studio. But as we have just 10 minutes left and you know how this works already with the Jupyter notebooks, I think it's good to advance a little bit. What can you do if you just have a normal Python script, right? But in a way also that is how you much more here and there will use these different IAAS services. Hence, let's go back to the clusters. Let's go to this cluster. And again, what I've shown you here from the Jupyter notebook area is basically here. Remember the story that I had to put first lots of permission policies to really get that all connected to be a specific user that is that really has the access rights, so to speak, to use this. But when we now use the EMR with the idea of a kind of typical Python script, it has to be in the cloud somewhere. And also the data, right? The input data for the application has to be in the cloud somewhere. Hence, we need a storage as a service. The S3 example of AWS connected to our EMR service and basically use it in some way. And this is a bucket store. We talk about lecture 8 a little bit more, and we already introduced it a little bit. So I go right ahead and see how the whole EMR workflow is connected now to this storage as a service, if you want. And here you see in the beginning, it's really planning and the storage. That means usually would do a very normal way of saying you basically just create a bucket here in the Amazon S3, a bucket which stands then for all different elements you want to put in. And this would be something where we upload the application and the input data. The application I picked this time with a Python script is actually, again, process food establishment inspections. So basically, this is something which you know a little bit from the food inspection data before, but this is a different data set marking then restaurants as different, let's say, violations in terms of red, in terms of columns. And what we want to do is have the top 10 establishments that actually have the most red flags, right? So pretty easy. We count here independently and then have summary statistics. Who is actually the one with the most red? And we want to have the top 10. So a very trivial application if you want, but if you think about that, there are lots of violations. If you now would go maybe through terabytes of data, that would make a difference of using then essentially the service. Hence, we have to upload now the concept, so the source code that you see here. Also here, I don't need to go in very much detail. We have this restaurant violations. We give n via an argument from the data source. This is a CSV file. I come to this in a moment. Then we open this in the PySpark environment, of course, that we import here with the Spark session. We work on it. We perform some SQL with Spark. You remember we had this also in one of the ideas, and then have this red violations counted. And under the wire, then we want to basically put that out again as a CSV of what are the top 10 of these which have the most reds. So in a sense, this is now something which doesn't really require a Jupyter notebook. Instead, we have some input and output parameter, and I want to show you how that also can be done in a EMR environment. But take away the message that we create the bucket food inspections 1 with the health violations Python script, which is actually this fellow here. What's missing is the application input data. So we put that also in the same bucket here for this application food inspections 1. where this is basically here as a CSV file. This is done via nice upload. You see how that works. Blue, red indicators here of the violations and so on. And there are many, many, many of those, and we want to work on this. Hence, the next steps are, of course, thinking about how we now add a step in terms of computing. To go ahead now, I will go to this cluster. You say it's waiting for us to work, so we can have some steps here. The steps will lead us to the different applications we installed. If you remember, I clicked on Hive, I clicked on Spark. In previous lectures, I did streaming, so I encourage you also to go back to the cloud computing maybe on 2022. I did the streaming program with MapReduce or something different, but I thought this time we do much more, maybe also a Python script, because Python is also getting more popular. And here we need this application location, and no surprise, we have now the S3 bucket that I can browse, right? So we go now to the Amazon S3. I uploaded there, as I had it on the slides, the food inspections 1. And no surprise, there's a health violations Python file that I uploaded already that I'm choosing now and can also connect to. And then there's some options that I also have to do here, or arguments more notably, in order to have now the input basically parameter. And we here go quickly to the slides to see how that exactly was there. You see we have to do here data source S3 food inspection, food established data CSV. And here I would recommend the following, that when you do this, it's very important that you sort of use copy and paste of the tool, right? I saw many programs failing because people tried to now actually put that in on their own. Hence, what I recommend when you work with the S3, basically create another idea of a service part here. Instead of over here, go maybe again to the MS Azure console, open it again, and then go into a different, sorry, not MS Azure, yeah, an AWS, right? So go again here and then go to the bucket store. In this sense, you can also directly copy paste the right bucket parts and folders and so on. And this is really a lessons learned over years that is important, because the devil is in the detail of very small things. So how I mean this is, you see here, when we now want to have the data source, as I was alluding to here, we have the commando parameter minus data source, for instance, minus data source. I think I put it this way, data source. And then you would say there's something like an S3 bucket. And the data source I was alluding to is something I already have uploaded as well in the food inspections, here the food establishment. And what you can do is now you basically click on it literally, and usually have always here even a copy paste button where you have this URI. This is important really in your basically memory to copy and paste it. And this will prevent really small errors, which the feedback sometimes can be misleading, right, from the cloud. So I would really encourage you to not use this manually, but rather do what I do now here, really copy paste. Otherwise, you probably encounter some errors. And this is true also for the output URI here, that we're going to configure to see where the output is landing, because we say, I already did this here with success, so let's do this for the demonstration and maybe create a new folder, output folder 2, just that you see that we execute this again, folder 2. And then you have another folder that you, of course, can configure in many ways. But here you have the same idea, an output folder now. And in the properties, you have again our beautiful, pointer here that we can copy paste, but you really should use. It can be a bit technical, and it's not really like the web is HTTP, it's an S3 address. So now we basically, they are saying we have the food inspection health Python script. We say where the data source is. It was one of the commando parameters, and where we should write the output. So when we add this step, that means basically now that, we should have a name for this. It makes sense. Would say just CCBD inspections step. Of course, you should have a more clever scheme when you do this in a company, maybe dates and so on when you want to analyze something. And now this step is pending, so it works on it. Here again, we are on our cluster, right? It's waiting. The hardware is also waiting and running. So ready for us to do some actions on Spark. And here you see now that essentially Spark will working on this. You can have in the more recent versions in AWS also the idea of having more arguments here. The jar that is used for this is a command runner. And you see here a little bit what's happening now to the Spark submit, that we have this kind of Python script itself, the data source command where the data CSV file is with all the violations. And then the output folder should just give us a top 10 that's coming out. While we wait that this is executed, just some conclusion on the slide, because we're already also at the end. You see how quickly it can go when you're doing demos in the cloud. You basically could eat up easily hours and hours to show you all the functionalities. It's so rich and so many configuration options that it can be, of course, quite overwhelming for beginners. And also the changes that every now happen is, of course, something you also have to understand. As I said here, lots of new things came in, new since a year or two. So many of the things changed. For instance, when you look in comparison to my 2022 lecture recording on some of these elements. However, it's nice, and what we expect is now in output folder 2, there should be a success indicator with a file usually there. But then this part 00 would be then the CSV file showing you the top 10 red violations in terms of number counting. And underneath was, of course, now again, this divide and conquer, this idea of Spark being very, very scalable. So no matter how big this file would be, the CSV file as input, the chances are that basically Spark can nicely progress this in parallel, because it's in the end just counting violations, right? Statistics. And with this, you have a nice summary statistic giving you the top 10 here. And this is unfortunately already the end of this practical lecture. Needless to say, I could demonstrate much more. Again, thanks to my team here. And this, we have a look, however, shortly, what the outcome of this application is. If it's already there, you see it's completed. It was a very tiny application and the data set was not so big. Hence, you can imagine that, of course, here in a really production setting with gigabytes or terabytes, it will be not 44 seconds to work on. But we want to see this. So let's look in food inspections in our nice bucket store in the S3. Look at output folder 2 and see what's happening here. When we refresh, we see in output folder 2, the newly generated one just right now. We have a success here. And also in the part when we do the CSV file here, we basically see the opportunity that these top 10 are there. The best thing is actually to download this file. We can do this with the download button here, for instance, because it's an Excel script. When we open it, then we basically see the top 10 that you see, hopefully also on the slides. So Subway, T-Mobile, and Taco, and so on and so on. Right. This is all documented also on the slides, and I think this also shows a little bit how AWS works. We will now continue basically going then to the deep learning, to machine learning, much more. Also a very popular idea how to make use of big data and clouds. So talk to you next time.